Ever wondered why an MSA bias study is so crucial to the world of quality engineering? Well, it's because this study is instrumental in determining the accuracy of a measurement system. It checks for systematic errors or bias in the measurement system, which can lead to inaccurate results and, consequently, poor quality products. So, how does one conduct an MSA bias study? It's a process that unfolds in several steps, and today we'll delve into each one. First, gather all the necessary materials. This includes a standard or reference part with a known value, the measurement system to be tested, and a trained operator to conduct the measurements. The key here is to ensure that the reference part is stable, meaning its value doesn't change over time. Next, measure the reference part multiple times. Typically, a minimum of 25 repeated measurements are taken to provide a substantial data set. This repetition is critical to detect any systematic error or bias that may exist in the measurement system. Once the measurements are taken, calculate the average of these measurements. This average will serve as an estimate of the measurement system's output when measuring the reference part. Then, subtract the known value of the reference part from the average measurement. This difference represents the bias of the measurement system. A positive value indicates that the system overestimates the true value, while a negative value suggests an underestimation. After determining the bias, calculate the uncertainty of the measurement system. This involves using statistical methods to estimate the range within which the true value of the measurement lies. The uncertainty should include both the bias and the precision of the measurement system. Finally, compare the bias to the measurement system's acceptable limits. If the bias falls within these limits, the system is considered accurate. However, if the bias exceeds these limits, corrective actions need to be taken to eliminate or reduce the bias. In summary, conducting an MSA bias study involves gathering materials, measuring a reference part multiple times, calculating the average measurement, determining the bias, calculating the uncertainty, and comparing the bias to acceptable limits. It's a process that demands meticulous attention to detail and a solid understanding of statistical methods. But the payoff is invaluable: a reliable, accurate measurement system that ensures the production of high-quality products. Because in the end, quality is what truly sets a product apart in today's competitive market.